In this video, we're going to talk about logical data. Logical data is data where there are only two possible values, true or false. In general, this comes about when you write code that asks a question that could either have a yes or a no answer. For example, you can compare two values. Is 10 greater than 9? Or perhaps more interestingly, does the variable x hold the number 3? The way we make these comparisons is with logical operators. You can see a variety of these in this table here. The first row, for example, we have the less than operator. Here's an example. Is 10 less than 9? Well, no. And so the result of this expression would be false. Similarly, we have the greater than expression. We could say, is 10 greater than 10? And again, the answer would be false. Because 10 is not greater than 10, 10 is equal to 10. If we want to compare whether two values are equal, we can use this equality operator, which is a double equals sign. We could say, for example, is x equal to 3? And that's going to depend on the value that is assigned currently to the variable x. If we want to do a combined greater than and equals or less than or equal to, then we can combine the greater than or less than symbol with an equals symbol. We can also create more complex expressions where we include multiple comparisons. For example, we could try to see if one of two expressions is true. For this, we would use this OR operator, which is a vertical bar. And that says if either of the expressions on either side is true, then the total result will be true. So for example, here we have 2 greater than 3, and 3 is equal to 3. Okay, except that it's the numeric value 3 and the character string value 3 that we're comparing. And in this case, the final output is true. So we know that one of those two expressions must be true. Well, we know, I hope, that it's not 2 is greater than 3, because clearly that's false. So this thing must be true, right? The number 3 is equal to the character string 3. And this does actually evaluate to true, this second expression. The reason for that is because when you compare data of different types, like we're doing here, R will try to convert them to be the same type. So in this case, it would convert the number 3 to the equivalent character string version, which would just be the character 3, and then it would say, oh, those two things are equal to each other. If instead you wanted to do something where you said, are both expressions true, then you would use this AND operator. Okay, in this case, the total result is false because even though the second expression is true, the first expression is false. And so in this case, we don't have both expressions being true. We can assign a Boolean value to a variable, just like with a numeric value or a character string value. We can also assign the result of a Boolean expression to a variable. We're comparing to see if 10 is less than 9, and that's false. And so that result gets stored in E. Now, if we print out the value stored in E, well, then we just see that's the result of that expression. One other useful thing to note about these logical values is that as far as R is concerned, they can be equivalent to numbers. So the value false is regarded as equivalent to the number 0, and the value true is equivalent to the number 1. So if you were to do a comparison of equality with the equality operator, then R would convert these two into the same type of data, and it would say, yes, they're equal to each other. The result is true. Similarly, if we were to compare 1 to true, then R would say, yes, those are equivalent. However, what we see is that other numbers are not regarded as equivalent to these logical values, right? So we can say is 2 equal to false, and or is 2 equal to true, and we know that both of those must be false because this is an or condition. So the fact that the total output is false means that both of these must also be false.